Joe, I'm thinking we should change the strategy slightly, and I'll explain why. Over here is a blow-up of the SAS144 sequence, and this is the plasma that has the insert. So, this region right here is the diff sequence that we want to use eventually to introduce this whole piece of DNA into the chromosome of Bacillus subtilis or some other, maybe even C. difficile. And here are those restriction sites that we were looking at yesterday, and here's that cell site. Thinking we don't want to use that, and let's use this SphI site instead. And the reason why I think that would be a better idea is, for one thing, Hendy3 and Sal don't get along very well in terms of a single reaction condition. There isn't a buffer that works very well for both of them. Plus, we can do something that would be easier than I was thinking originally, and that is we can take this plasmid PUA321 that has the reporter gene construct that we want to introduce into SAS144, and we can do PCR from a sequence right about here and a sequence right in here and amplify that fragment. So that would look something like this, where we'd have the reporter gene, we have the promoter region, and an SPH1 site right here at the beginning of the promoter region, and that Hendy3 site right here at the end. And then we can just cut this PCR product with SPH1 and Hendy3 and generate sticky ends that we could then clone into the region right here. That way we wouldn't have to order any primers because we've got this primer, which is called TP002, and this one is called UP Pro for promoter, R for reverse. So we have both of those. We could do the PCR, next week if we wanted to. And then we've got the enzymes, and there are conditions that SPH1 and Hendy3 work in the same reaction. So maybe today we can try the digest just with the SAS144 that you purified and verify that that's true, that each of those sites work, and then next week maybe do the PCR.